Welcome to the Explainer. Today, we're jumping into two really classic design patterns that solve, very different problems, but in these elegantly simple ways, the adapter and the facade. All right, let's get right into it.
I mean, we've all been there, right? You've got two things that really should work together, but they just don't. Their interfaces, their shapes, their connections, they're just completely off. This happens to us all the time in the real world, and let me tell you, it's an even bigger headache in software development.
So let's start with what I like to call the misfit problem. Yeah, it's that classic situation where things just refuse to connect, and it's something I bet a lot of us know from our day-to-day lives. Okay, picture this. You just landed in London, you get to your hotel room, your phone battery is screaming at you at 2%, and you see this on the wall, the classic three-pronged British outlet. It's just sitting there, ready to give you all the power you need, or so you think.
But then you pull out your trusty laptop with its very American two-pronged plug. And just like that, you've got a problem. You have the power. You have the device that needs the power, but there is a fundamental mismatch. You can't connect. And here it is, the hero of our story, the simple power adapter. Now, think about what it does. It doesn't change the wall outlet, and it definitely doesn't change your laptop's plug. Nope. It just sits right in the middle, translating one interface into what the other one expects. It's a translator. That's its whole job.
And this exact problem, this exact scenario, happens constantly in our code. You've got an existing system that expects an object to look and act a certain way, with specific methods. Then you try to plug in a new library or components, and its methods have different names, different signatures, they're totally incompatible. So what do? Well, you need a software adapter. Which brings us right to the adapter pattern. Think of it as your code's universal translator. And we're going to see how this works using a really fantastic and, slightly feathered example from the classic Head First Design Patterns book. So imagine this. Your whole application is built to work with duck objects. It knows all about ducks. But today, you've run out of ducks. All you have are these new turkey objects. Now, you want to use these turkeys in your system just like they were ducks, but they're not. They're turkeys.
And here's where it all breaks down. Just look at the slide. The interfaces simply don't match up. Your system expects to be able to call a quack method, but a turkey, it only knows how to gobble. And yeah, they can both fly, but a turkey just flies in these short little bursts, not like a real duck. The interfaces are similar, but they're just not compatible.
This is where our adapter works its magic. We create a new class, a turkey adapter. Now this class pretends to be a duck. It implements the duck interface, so it has a quack method that our system can call. But, and this is the clever part, behind the scenes, when your system calls quack, the adapter just turns around and tells the turkey object inside to gobble. It's a perfect little translation layer. And that leads to this perfect, kind of cheeky summary from the source material. To the rest of your system, this turkey wrapped in an adapter is completely indistinguishable from a real duck. It responds to all the right messages, even though, secretly, it's doing something totally different on the inside.
So, to put a formal pin in it, that's the adapter pattern. Its one and only job is conversion. It's all about bridging that gap between incompatible interfaces, letting two parts of your system that were never meant to speak to each other work together like they were old friends. Okay, let's totally switch gears. We're going to look at a completely different kind of problem now. This one isn't about two things not fitting together. No, this is about a system that's so ridiculously complicated with so many moving parts that just using it is an absolute nightmare. So imagine you've built this incredible home theater system. Amazing, right? But to watch a movie, you have to go through this insane checklist. You've got to turn on the popcorn, start the popping, dim the lights, put the screen down, turn on the projector, set the mode. It's exhausting just reading it. And you have to do it all in the perfect order or the whole thing just doesn't work. So what's really going on here? The problem is that you, the user, are being forced to interact directly with this whole subsystem of complex components. Every single one has its own interface, its own settings, its own little quirks. The sheer complexity for a simple task, just watching a movie, is totally overwhelming. So, how do we fix this mess? Well, the key here is that we're not going to change any of those individual components. We don't need to. Instead, what we're going to do is build a beautiful, simple front door for the entire system. And that is the facade. And this is the facade pattern in action. In our home theater example, we'd create something called a home theater facade. This is one single class whose entire job is to be the new, clean front of the building, hiding all that chaos and complexity behind it. So now, instead of that ridiculous 11-step checklist, your code makes one single, beautiful call, hometheater.watchmovie. That's it. The facade gets that simple request, and then it does all the heavy lifting. It talks to the lights, the projector, the amp, the popcorn popper. It handles all of that messy coordination, hiding it completely from you. And that's the formal definition. See, unlike the adapter, a facade's job isn't to convert an interface. Its job is to simplify one. It gives you a single, unified entry point to a whole mess of other objects, making the entire subsystem way, way easier to use. Okay, so this is probably the most crucial takeaway. Both of these patterns wrap other objects, right? But they do it for fundamentally different reasons. And understanding that reason, their intent, is the absolute key to knowing which one you need. Here it is, the whole thing in a nutshell. An adapter's intent is to convert. It makes one interface look like a different one. A facade's intent is to simplify. It takes a whole bunch of complicated interfaces and gives you an easy one. Convert versus simplify. If you only remember one thing, remember that. So let's just bring it back to our real-world analogies, because they're perfect. An adapter is that power plug adapter. Its whole purpose in life is to make an incompatible plug fit. A facade, on the other hand, is that universal remote with the one big watch movie button. It takes a dozen complex steps and boils them all down to a single, simple click. All right, so let's just quickly recap the main points. You're going to use an adapter when you have a mismatch and need to make two things work together. You're going to use a facade when you have a complex system and you just want to make it easier to use. An adapter changes an interface, while a facade hides complexity. Get those two and you'll know exactly which tool to reach for every time. So there you have it. We've met the adapter, our code's great translator, and we've met the facade, our great simplifier. Now, I want you to think about the systems you're working on right now. Is there a place where things just don't connect? Or is there a corner of your code base that's just a nightmare of complexity? Which one does it need?